Please welcome, with Ticketmatic, Ruben Vermeersch.
Hi. Hello. All right. So hi, everyone. Welcome back. I'm Ruben. I come all the way from Belgium, and I work at Ticketmatic, our ticketing company. So we build a software as a service platform for concert ticketing mainly, for more complex venues. We're based in Belgium, the Netherlands, and we're setting up shop over here as well. Just to give a quick idea what it looks like, we have highly customizable sales pages. There's a full back office and box office. There's some very cool visualizations and some interactive, powerful editors. This one, for instance, is a seating plan where you can assign different categories of seats. As you can see, it's all in the browser, so it's just a big web page for the most part, a web application. So today I will be telling you about how we went cloud native with Kubernetes. And to understand how we did this, we have to know where we came from. And that was probably, as most IT companies, our own servers in different data centers, which is fine until things break down, usually on a Sunday at 3 or 4 in the morning, and then you can get to sit in one of our more glorious offices, which I do not recommend. This was a traditional web application architecture, so it started out in the earliest versions as just like a LAMP application, so some PHP with a database behind it. It has since split up into the strategically partitioned monolith, not full microservices yet, but it's a bit more modern now. The biggest problem, though, was the management pane. So we had no real fixed processes in deploying things. It was a matter of syncing files to the right servers, installing packages on the right things, and doing it all manually, and most of the time errorously. And especially if you wanted to keep multiple environments in sync. So we had a development environment, a staging environment, a production environment, and this was all a manual process. So big pains, which we really wanted to solve if we wanted to accelerate the company. And then Docker came along, and Docker was supposed to fix all these things. And if you remember their marketing material from when Docker was launched, there was this slide where they reasoned that for each kind of application and each runtime environment, you used to need like a different version of your application or a different artifact. And Docker, the universal shipping container of software, was going to fix all of this. So yay, great, except it didn't. Because what about deployment? How do you deploy Docker containers to your servers? You still have to manually pull them and start them. What about multiple machines or orchestration between your services? That was all still a manual process. So it turns out that Docker, back then, now it's a different story, but back then it was just a packaging format, and it was still all manual. So nothing really solved. Made things a bit easier, but not much. So when Kubernetes came around, it really resonated, and I'm guessing for a lot of people, because based on the experience at Google for many years, they solved these really hard problems. So good, that's where we want to go, we said, and that's what we did at some point. Actually, Brian over there convinced me 2 years ago to do this, so I'm happy to be telling you now how we did it. So this is going to be our story. But it might just as well be your story in the sense that apart for some special needs, ticketing is, well, just a basic web application. And most of us nowadays have web applications. So it's going to be our experiences, some lessons learned, what you can do. And it's going to be not the whole process and the whole story and all aspects of it, but 2 specific angles on which I want to draw some attention. But before we got there, the first step for starting with Kubernetes is to get your cluster running. And I must give a big shout out, a thank you to the people from CoreOS, not just because we're on the conference, so I'm obliged to. No, because they make Container Linux, which works really well and solves a real painful need, but also their documentation is really top-notch. So we didn't use Tectonic because back in the day it didn't have a high availability control plane. It does now. But their documentation on setting up your own Kubernetes clusters is just fantastic as well. So good stuff. But then what? So you have your cluster, and then you have no clue what to do with it, let alone that your company will suddenly be cloud native. And this confusion is a bit normal because it's super easy to get the cluster running, but then it all becomes a bit more vague in what you should do and what the right things to do are. The infrastructure is only part of the story. And what about operations and what about development? That's two small areas of pain I want to highlight today. Let's start with operations. It's the first step up from infrastructure. It's the people that are interfacing with the infrastructure. And the standard Kubernetes CLI, kubectl, is really great. It takes a bit of a learning curve, but it's a Swiss Army knife that solves all your problems once you get to know it. It works really well, but it's also super low level. So it's all very manual work, and it's like pointing at bits, and it's not a big picture. There's not a big workflow in there. And this, again, gives you some operational difficulties. Suppose you have multiple environments, a development environment running on a laptop, a staging environment or QA, and a production environment. How do you repeatedly replicate the same setup in different environments, and how do you do this process reliably, ideally testable, so that when at some point your infrastructure, and by which I mean your set of services and deployments, all these kind of things, when they evolve, how do you make sure the same evolution happens correctly in the different environments that are there? With no room for errors, so this usually means no people involved. And we really wanted to handle all these multiple environments with just one set of configuration files, so one set of YAML manifests, without having to manually select this one is for development, this one is for production. That's what we set out to do. And we started prototyping things to investigate the problem space, and we came up with kubeapp-deploy, which, as most of the time with these kind of things, stuck around for way too long, and we're still using it in production, but it works really well. And what it does is it takes your set of manifest files, so the YAML files, but it treats them as templates, standard Go text templates, and it adds variables and control flows, which you get for free with that. And that's basically it. So it's on GitHub. But let's have a look at what this actually means. So here's a very simple example. This is still a normal Kubernetes manifest file, the YAML file. But the last line shows the difference. There's variable interpolation now. So you can use kubeapp-deploy to substitute variables in there. And I use this example here on the slide. It's very simple. I just inject a value of which environment we're running in, and it sets an environment variable. But you can also use it for more complex things. For instance, our continuous integration system, whenever it builds a Docker image, it records the tagged full qualified name of the Docker image. And we use kubeapp-deploy to substitute this into our manifest files. So we don't have to adjust our deployment configurations for each new version we build. It's the CI system combined with kubeapp-deploy who generate this final result. You can also do control flow. For instance, wrap the whole block in an if statement, and depending on how it evaluates, either you end up with the deployment or with nothing, so it's just ignored. And this can be used for useful things, such as if you use DynamoDB in development, you might want to run the fake version that Amazon provides for development and run it as well in your development environment. But you don't need it in production. So we have a variable for that which takes it out in production, and there we use the software as service provided by Amazon. But you can also put like control flow inside of the configuration file, inside values, or anywhere to make things conditional. We'll see an example of that later on. So that's it basically. And to run it, to deploy your application to a cluster, now it becomes a matter of just using the kube app deploy CLI. And you point it at a folder, and it will load variables from either a variables.yaml file or from the CLI. You can add extra parameters. Do this, or embed it as a library into a bigger whole, as we're doing. Now what kube app deploy does is it takes your templates, your variables, it renders the whole thing, and then it comes up with like a final set of manifest files. And it will then look at your cluster and does like a reconciliation loop where it will add new things, remove things, adjust things. And we assume ownership of a full namespace. So if you have a couple of defined deployments in your configuration and some others in the namespace that are not specified anymore, we'll wipe them. So big caveat. So what did we gain with like a very tiny thing, because it's not very big? We have one set of manifests for the whole product throughout the whole life cycle of development to production. And we've taken the fat finger out of the loop. So there's no human like process involved anymore in a deployment besides starting it. And that's a big gain in its own. Now, if you know the Kubernetes ecosystem a little bit, this might look very familiar. It looks like Helm, and that is exactly true, because it does the same thing, except Helm nowadays does much, much more things. So why don't we use Helm? Well, probably we should, and I recommend you look into it. We started doing this, and we built kube app deploy, and then we ran into Helm, which was much broader in scope and alpha back at the day, so we stuck with the thing that was stable for us. But do look at Helm. It has some very nice other features like lifecycle hooks. And if you're interested in Helm, I think the next talk right here is about Helm, so stick around. One other thing to mention, it's very new. It's not very known yet. I'm not even sure if it's on by default nowadays, but it's pod presets. And pod presets allow you to specify a little piece of configuration, like I want to inject this configuration map into my pod, put it in a preset, and what will happen is anytime a new pod is scheduled, either manually or through a deployment, this little bit of configuration will be injected. So this helps to move some of the variability into one place. Doesn't really help you with conditional deployments, and there's a bit of a danger of becoming untransparent. So if you have lots of these, it becomes a bit more difficult to find out what actually the final result will be. But still, this might help. This might be useful, so have a look at it. Could help you out. So yay, progress. It's good. You have to know that initially, the Kubernetes project, it was really built up from the ground up. So they added pods, services, and replication controllers. And these later become replica sets. And once all of this was stable, they added extra things like deployments. So the engineering focus of the project is to begin with like a solid foundation. And that's a very good thing. The problem is, if you're not a developer, if you're a user of Kubernetes, and you come in and you want to use it, then it becomes a bit more unclear the higher up the levels of abstraction you go. So when we started using Kubernetes, there was no story about how you do application lifecycle. We should probably advertise this a bit more, and Helm is a good step in the right direction. So that's good. Let's look at development, and that's another step up, a step further away from the infrastructure, and that's a bit more undefined and vague. And the thing is why you should pay attention is not because it's hard to convince developers on the merits of Kubernetes. Most people who work with like backend services or something related to any non-functional concern, they will quickly understand why Kubernetes is super great. But it's the functional developers, and I don't mean Haskell or anything. I mean the developers working on like the actual functionality of the application, the ones doing the front end and maybe doing some back-end endpoints and the integration between it. They usually don't care about the infrastructure or the new toy that the infrastructure guys come up with. But speaking from experience, if you make their life miserable, these developers, they're not going to be very happy to adopt something new. So don't make their life miserable. Try to make their life better in the transition. And that's something we try to think about a lot when going to Kubernetes. Also because it's an opportunity to rethink some things. And the reason why you have to do it is because theory, more often than not, and especially in software engineering, is different from reality. If you look at microservices theory, it states that you should build your services in isolation, ideally tiny ones, and you have to mock out your dependencies and do everything with unit tests and contracts. But it doesn't work out that way. You usually either the contracts aren't being honored or screwed up, or you come into a situation where you have a complex flow of things which you need to like poke at the same time. So whether you like it or not, whether you try to stick to the theory or not, at some point you will need the whole environment running and tweakable at the same time. Or maybe not the whole environment, but a big chunk of it. So you can't really do this, like do one thing at a time. So that's where we really try to have a look at and say, like, can we improve this problem? Now, another problem, if you're going to Kubernetes, you have to keep the development cycle in mind. And for all of its bad parts and let's say horrible parts, a PHP developer, for instance, has a really great development cycle because he's used to writing the code, hitting save, and then making a new call or refreshing the page, and it's instantly there. So they have like instant feedback and a very rapid development cycle. In some other languages, that's not the case. If you put your whole development environment into a Kubernetes cluster, for instance, in a virtual machine with all the pods and containers, the development cycle becomes much, much more heavy because you have to build your application, which you have to do anyway, but then you have to package it in a Docker container. You have to upload this Docker container to an image registry and then start new pods or adjust the deployment, which in turn will start new pods. So this becomes like a long and cumbersome process. And we didn't really want to do this because we were used to, either for PHP, which unfortunately we still drag along, or for Go, we were used to having this instant like cycle of doing things. So could we have a live reload for cloud services? That's one of the things we wanted to do in our quest to a better development environment. And we wanted to make things simple. Nowadays it's built on a Vagrant image, but there's this thing called Minikube, which starts up like a small Kubernetes cluster, and this sounds like an excellent target for doing this kind of thing. And what we want to do is you do a git pull of a configuration repository, and you do start, and it starts the whole development environment, regardless of how many components you have in your application. And this is very important because you want to do this so that there's no extra overhead for those developers who don't care. You want to make it really simple for people to either get on board or to work with the platform without having to know all of Kubernetes or all of the ugly little secrets you have inside your software stack. So we set out to build a developer tool at Ticketmatic, and we had long creative sessions on thinking up a good name, and we came up with Devmatic. I will now, just to show you what it looks like, and perform in one of our favorite extreme sports called the live demo. So bear with me. Let's see. Okay. So Devmatic has a web interface. It's a dashboard. And I know Kubernetes has a dashboard, but the Kubernetes dashboard is extremely low level. It's actually just the same thing as the CLI, and it has a million bits and bobs which you can tweak and adjust. And it's a bit hard to see what you have to do, especially as a new user. So we realized that we should make a simple dashboard. And one of the other things we also realized is that most of the time, unless you are working on special things, users, and by users I mean our developers, they only reason in the logical services available in your project, which usually map one-to-one to your deployments. And usually in your development environment, you also be running one pod per deployment, so a replica factor of 1, because it's on a laptop. So we just reason in terms of deployments, and that's all you get to see on the screen. There's one important action. It's up here in the top right. It looks like a reload icon, for lack of a better one. I'm not a designer. And what it does is it starts a deployment cycle. Now, what this means is that it will download the newest manifest templates from our server, interpolate the whole thing, and run it against your local cluster. So a developer has one button to make sure that he's up to date with the newest version of every component in the system, without having to take care of adding new things and all this kind of things. So it's a one-click process, regardless of what happens. That's a good thing. Now you can drill down into each of the servers, and one of the seemingly trivial but very important things is this. There's a log view. When we started out with Kubernetes, every time you get a new pod, it gets a new name. So you have to copy-paste this identifier to get the logs, to get the output of whatever service was failing now. So just by embedding a log view in here, we saved a ton of time. And it seems trivial, but it's these little things that add up. Similarly, if you want to drop into a shell for one of your services, there's this computer icon here. Click it and you get a copy-pastable command to run a shell into this container. We could have embedded like a very nice JavaScript terminal in here, but A, that's a lot of work. B, it's usually not that nice. Your own terminal is usually the one you really like. And see, this works good enough for us, so let's keep it at that. This is good enough. But every time a new deployment rolls out, the identifiers change. So just being able to copy-paste this into a terminal and being into the shell saves us a lot of time. Now it has some other nice features, such as a development mode. Like I said, we wanted to have this live reload for cloud services. Now there's this mode column over here with all the little cloud icons. These signify that this service is running in image mode. And that's the image built by our CI system. That's also the image that will end up in production. So everything with the cloud runs exactly as it will run in production. But what you can do, you can go to one of the services, and you can switch it to development mode. If you do that, so let's do this, if it works. So what happens is, a new container will be scheduled. It has a different base image, Go Rerun. In this case, it's a Go project. And Go Rerun is, it's a version of doing Go Run on your source code, except that we can poke it externally. And I will show you what I mean. So say we edit something. Super simple, but you get the idea. We're working on software. Just hit the reload button, and the process will be restarted inside your container. Now, why is this great? It's because it takes like not even a second. So you edit some code, hit the button, and it runs. You should still do unit tests. But for those cases where you have to work with the live software on the live environment, this is a huge time saver. I will show you later on how we do this, but it's instant and it's nice. So that's a good thing. So we're back at slides, which means nothing went wrong, or nothing you noticed. So we've seen this, that's good. How does this work? Well, the dashboard it's not that big actually. It's kube app deploy, plus a lot of glue code that talks to the Kubernetes API. And there's a very good library by the Kubernetes people, client Go. It's a bit heavy, but it works really well. And it allowed us to build this integration. And you've seen it. It does like real-time updates of the web interface, and all works really nice. And to borrow from some terminology by CoreOS, it's a self-driving deployment. So the dashboard and the machinery behind it will periodically check with our servers if there's a new one, and if so, it will adjust its own deployment because it's also deployed as a Kubernetes pod, and then do a rolling upgrade of itself. So we don't have to do anything for it. So how does this work for source mode? It looks a bit ugly, but what happens is you add an extra annotation to your pods, and what it basically says is that in this deployment, the queue container, which is defined near the bottom as well, runs in a go mode. And this tells our tool, like, you have to do go get instructions and make sure that the right paths are available and this kind of things. And the go path where this piece of software is running is specified as well. One other change we do to our deployment manifest, it's a bit of convention, is we have this conditional control flow in there, which switches between the image version, and there you see the variable that our CI system inserts with the correct reference, or it switches to the Go rerun image, and it source mounts the source code in there. It's not ideal because you have a bit of a mismatch between the production environment and what you're currently developing against, but it's good enough. And as long as you do your integration tests against the real thing, which you should, then this hasn't given us any problems. Let me say it like that. So the nice part about this is that it has been like trouble-free uptake. We used to have a Vagrant image with a lot of the services installed, but nothing more. We could tell our developers to throw it out, install this, and we made sure that we kept the port mappings, etc., the same, so everything worked as well. And the nice part is that some people don't know about Kubernetes, but they can use this, and it allows them to be very productive. For the side of things where you maintain this platform, it's also very nice because it's self-driving and auto-updating, so we don't have to ensure that people keep their Vagrant box up to date, and that when weird things start to happen, we don't even have to check if things are up to date because we know they are. So that saves us a lot of time. But the sad truth is we shouldn't have to build this, and neither should you. So it's a bit of a shame that we as a ticketing company have to build the developer tools. So let's round up a bit. Let's go with some conclusions here. First of all, if you want to go cloud native, I highly encourage you to think about all your stakeholders because it's a process that doesn't end with infrastructure. It goes to operations, and it even affects your developers, at least if you want them to do things in a way that is somewhat similar to how it will be run in production. You should invest in their experiences, and it usually pays off because by doing this, we could make the life of some people easier, so suddenly they were also a driving force to get this adopted. And I also want you to realize that it's normal to be a bit confused. That, at least for us, that was a big thing. The Kubernetes is really great to get started, but once you get a bit further away from the cluster, it's like, what the hell should you do? And this was touched upon this morning as well in the keynote, very similar. But don't let any of this discourage you. It's still a fantastic platform, and it's super stable, and it hasn't given us much misery so far, fingers crossed. So I still encourage you to do this. I'm not sure if I want to encourage everyone to take the whole exercise of building the tools around it. Let's get to that. Now, as a project or a community, I still think that working from the ground up is fantastic, but we have to realize that as all these like options and keeping things like undefined and providing no real guidance quickly becomes a bit confusing for new users. Or worse, it might lead to the fact that each and every company has to figure out these things themselves or figure out how we should do good development tools. And I hate the word standardized, but it's probably the right one in this context. We should probably think about what can we standardize upon. And this morning, when draft was announced, got me a bit off guard, obviously, but I'm very happy to see this coming around because this is a very similar solution to a very similar problem, and it's coming from the Helm people, which is a good sign because that makes it slightly official. So good. There's progress being made there. And with that, I would like to hear some ideas as well. So if you are involved in this or if you have the same problems, let's talk about this. We can improve on this and make it easier for people new to the problem space and to get more people to actually adopt Kubernetes as a result. So thank you with that. I will also mention that I will put slides online soonish on my website. It's rocketeer.be. I'm also obliged to tell you that we're looking for new people. So if you need a new technical challenge or if you want to help us conquer new markets, do come have a chat. So thank you. I think we have like 5 minutes for questions. So excellent. Thank you. There's a hand over there.
Not really a question, but mostly a comment on this. We at Mailgun also had the same problem.
Probably.
And we built our own dev tool called Devgun.
Oh, wow, excellent.
Creative thinking, right?
Yeah.
But yeah, we had very similar problems. And actually, I was really, really happy to hear the way you solved some of the problems that we're going through right now, trying to figure out how to differentiate between the production containers and dev containers, and that's really cool. I'd love to talk afterwards.
Okay, cool. Thank you. Let's have a chat. So, over there.
Kind of a follow-up on that is, have you released any of this in the open source?
So have we released any of this in the open source? Yes, Kube App Deploy is open source. It's tiny. I try to make a habit of releasing bits and pieces where possible. Now, the whole dashboard thing you saw isn't open source yet or won't be, because there's some like things specific to our way of working. We have to think about how we can generalize this as a general way of working. I think that the draft people have thought about this a bit more, so it might be interesting to see what they do and how this, either we open source some of this, or we contribute some of the ideas, or we try to like pull the right people in the right direction and get this working. So, yeah.
So in the web interface that you showed of like the kubectl command that a developer would be able to run, did you or have you experienced any friction with developers kind of going, I don't want to understand any of that orchestration system on the other side, or have you had a pretty reasonable like acceptance of that and folks sparking curiosity to work with it?
Yeah. It's pretty okay, actually, because they don't really have to understand the orchestration side of things. So if you can tell them, like, this is an abstract-looking command line, but what it does is it gives you a shell in the container, then it's reasonably okay that they don't know the bits and bolts behind it. So that's fine. There's no real Kubernetes knowledge involved or needed for this. Now, the nice part about not hiding everything between like one command that does everything is that for those users who still want the full power and who do like if you have a service that integrates with the Kubernetes API and does its own lifecycle management, they can still do that. So we don't try to hide everything. We just try to make it convenient enough to get started, and then you can like step up at your own pace in terms of complexity. So yeah. One more.
What is the local development environment based on? Can you tell us, is it Minikube? What developers run on their laptop?
Yeah, currently it's, I can even show you, and you might recognize it. This is still Vagrant. Also for probably the same reason that Minikube didn't exist back when we started this. And it's not that long ago, so things move fast in this space. Probably the better solution now is Minikube. But Minikube only recently gained the possibility to do volume mounting from the host system. And we rely on it for mounting the source code into the containers. So nowadays, you probably want to do it on Minikube because I have the experience that, or the feeling that Minikube is a bit more stable and solid and doesn't screw up with networking and these kind of things. Vagrant can be a tricky beast, but you have to roll with like the boat you have. Yeah. Okay. No one else? Thank you very much then. And let's have a chat.